Hi guys, welcome to lesson 7-2 Substitution. Our objective for today is that I can solve systems of equations by using the substitution method. What is a system of equation? It is a set of two or more equations with the same variables. The substitution method is when you solve one equation for one variable and substitute it into the other variable or equation. When are we going to use this? When is it most ideal to use the substitution method? When you have one variable in an equation that is already isolated or is easily isolated. That's what we're going to be looking for. So when we have is already isolated or easily isolated. So let's work our way through some examples. Our first step is we want to figure out, is one of these equations going to be easily isolated, right? So if I look at my two equations, I have y equals 4x minus 1, and I have 2x plus 2y is equal to 3. I see that I already have, in my first equation, y is already isolated. So that's the value that we're going to work with, right? So y is going to be equal to 4x minus 1. So we're going to take y out of the second equation, and we're going to substitute in 4x minus 1. So the way you could picture this is, you could have you're taking away a $1 bill and you're giving somebody 4 quarters. You're replacing one thing with something that is equally as valuable to it, right? So we take away the y and we're going to substitute in, we're going to put in what y is equal to, which is 4x minus 1. So our first step, we rewrite the equation. We have 2x plus 2 parentheses. We're replacing y with 4x minus 1. 4x minus 1 is equal to 3. All we did was we took the second equation and we removed y and we put in something that y is equal to, that is the same as. All right. So our next step here is we need to use distributive property. And so we get 2x plus 8x minus 2 is equal to 3. And now we're just back to old-fashioned solving. We're going to combine like terms. 10x minus 2 equals 3. And then we're going to add 2 to both sides. 10x is equal to 5. And our final step is going to be divide by 10. And we get that x is going to be equal to 5 over 10 reduces to 1/2. So now that I have a value for x, it tells us that we need to substitute that value into the other original equation to solve for our other variable. So we solved for x initially, now we're going to solve for y. So I'm going to take that purple value for x, and we're going to substitute it for x right there. So we have y equals 4 times 1/2 minus 1. All right, 4 times 1/2 is going to be 2 minus 1. And then we do that subtraction and we get y is equal to 1. So our ordered pair, this is what our actual answer for a system of equations. It's going to be an ordered pair. It needs to be written in parentheses, separated by a comma. Your x term first, so we have 1/2, and then your y term, 1. This is your answer. That is your final answer for a system of equations. You are looking for the point in which these two lines are going to cross. That is the only value that is a solution to both of these equations. So step 5 here is to check our answer. So we're going to substitute those values into both equations and make sure they work. Now we use the y equals 4x minus 1. It should work because this is where we just got our answer from. So we have 1 is equal to 4 times 1/2 minus 1. So 4 times 1/2 is 2 minus 1, and we get 1 is equal to 1, which works. Our second equation, we have 2 times 1/2 plus 2 times 1 is equal to 3. 2 times 1/2 is 1, plus 2 times 1 is 2, is equal to 3. 3 does in fact equal 3. So our So our value, our answer is correct. All right, so we're going to go on to our next page, and we've got some problems to try, some practice. So let's look at letter A. Letter A, we've got y equals x plus 1, y equals negative 2x minus 2. Now, both of these are solved for one variable. So I'm going to take this first equation, x plus 1, and I'm going to replace the y in the second equation with it. So I'm going to have x plus 1 is equal to negative 2x minus 2. Now we just have variables on both sides. We add 2x to both sides, and we get 3x plus 1 is equal to negative 2. We subtract 1 from both sides. 3x is equal to negative 3. And lastly, we divide by 3. X is going to be equal to negative 1. And now we're going to substitute that value in. We're going to pick one of our equations. I'm going to pick the first one. So we have y is equal to negative 1 plus 1. And so y is equal to negative 1 plus 1 is 0. So my ordered pair is negative 1, 0. That is my answer. Now, what if we had picked the second equation? What if I had picked that second one, right? Y would be equal to negative 2 times negative 1 minus 2. So again, you would have y equals 2 minus 2, y equals 0. It doesn't matter which equation you choose to use, you will get the same value no matter what. All right, let's take a look at letter B. Letter B, we have negative x plus 3y is equal to 0, and we have y is equal to negative x plus 8. So negative x plus 8 is what we're going to substitute in for y. So we're going to have negative x plus 3 times negative x plus 8 is equal to 0. Okay, so all we changed in that first equation is the y value, right? This is all that changed. Everything else is the same from the first equation. All right, now our next step, we need to distribute. So we're going to get negative x minus 3x and plus 24 is equal to 0. We're going to combine like terms on the left side. Negative x minus 3x is negative 4x plus 24 is going to equal 0. I see an opportunity here to get my variable to be positive, so I'll take it. I'm going to add 4x to both sides, and we get 24 is equal to 4x. And my final step is to divide both sides by 4. So I'm going to get 6 is equal to x. Okay. All right. Now, we're going to substitute that into our equation. We have y is equal to negative, and we're going to put in our value of 6 plus 8. Y is equal to negative 6 plus 8 is 2. So my ordered pair is 6, comma, 2. Now let's double check this. Let's substitute it into our original equation and see if it works. So we have negative x, so negative 6, plus 3 times y, 3 times 2 is 6. Negative 6 plus 6 is 0. And so our work checks out. All right, I want you guys to do letters C and D on your own and then check your work against mine. All right, letter C. We have our first bit here. We've got negative 5x plus 14. That's our y equal to y, so we're going to substitute that for y in our second equation. So we have 2x minus 2 times negative 5x plus 14 equals negative 4. So we need to do some distribution here. So we have 2x plus 10x. Okay, 2x plus 10x minus 28 is equal to negative 4. We need to combine like terms. 10x plus 2x is 12x minus 28 is equal to negative 4. Add 28 to both sides. You get 12x is equal to 24. Then lastly, we divide both sides by 12. X is going to be equal to 2. So now I'm going to substitute that into my original equation. Negative 5 times 2 plus 14. Y equals negative 10 plus 14. And that gives me that y is going to be equal to 4. So my ordered pair is 2, comma, 4. That is your solution right there. All right, let's take a look over at letter D. Letter D, we've got the first equation is solved for x. So we're going to substitute in 2y minus 3 for x into our second equation. So we have y minus 2 times 2y minus 3 is equal to x. Sorry, is equal to negative 6. And you'll notice once you substitute in, you no longer have two variables. You just have one because we took one of the variables away and we put in something equivalent in terms of the other variable. So we distribute. We've got y minus 4y plus 6 is equal to negative 6. My next step, combine like terms. Y minus 4y is negative 3y. Plus 6 is equal to negative 6. Subtract 6 from both sides. Negative 3y equals negative 12. And then we divide both sides by negative 3. We get y is equal to 4. And now we're going to take that and we're going to substitute it in to our first equation so that we could try to find our x value. So we're going to get 2 times our y value of 4 minus 3 is equal to x. 2 times 4 is 8, minus 3 equals x, and 8 minus 3 is 5 is equal to x. So my ordered pair is 5, comma, 4. So now that's a good example that we don't always have to solve for y every time. Y is not always going to be what our easiest variable is. In this case, x was already set up for us, so we used x as our substitution term. All right, now we're going to take a look at example number 2. And in example number 2, we need to solve first and then substitute. So this is that part of the objective of the day where we are, or not the objective of when are we going to use it. It's when we can easily isolate one of our variables. And in this case, we can easily isolate a y in my second equation, right? I can easily get that variable by itself with one quick step. And so that's what I'm going to do. I'm going to add 3x to both sides of my equation. And now I have y is equal to 3x plus 4. And now I have something that I can substitute in to my equation. And that's exactly what I'm going to do at the top of the next page. I'm going to take my other equation, which was negative 8x plus 5y, and I'm going to substitute in what I just created. So we have negative 8x plus 5 times, we solved it, and we got 3x plus 4 is equal to negative 1. All right, now we need to go ahead and use distributive property and solve. So first steps, negative 8x. We have 5 times 3, which is plus 15x. 5 times 4 is plus 20, and that is equal to negative 1. Combine like terms, and we've got 7x plus 20 equals negative 1. Subtract 20 from both sides. 7x is equal to negative 21, and we divide by 7. X is going to be equal to negative 3. Now we can use that equation that we just solved because we're trying to find y. So we're going to take our y or our x value and we're going to substitute it in. So y is equal to 3 times negative 3 plus 4. So y is equal to negative 9 plus 4. Negative 9 plus 4 is negative 5. So there's our ordered pair, negative 3, negative 5. Now, when we check here, what we should always do is we should always go back to the original equation that we started with to check our work, just to make sure that we didn't make a mistake in converting into, solving for a variable. So this is just kind of a double check on everything that we've done so far. So we substitute in, we have negative 8 times negative 3. All right, and we are plus 5 times negative 5 is equal to negative 1. Negative 8 times negative 3 is 24. 5 times negative 5 is negative 25 equals negative 1. So 24 minus 25 is negative 1 is equal to negative 1, so that checks. And if we check our second equation, we have negative 3 times negative 3 plus negative 5, and that's going to equal 4. Negative 3 times negative 3 is 9, plus negative 5 is equal to negative 4. Sorry, not negative 4, positive 4. And 9 minus 5 is 4, and that does in fact equal 4. So we know that our point is correct. All right, so now we have two problems to try here. So if I look at letter A, I see that my top equation is really the one that I'm going to work with, that I can easily get that y by itself. So I'm going to add 2x to both sides. And what am I going to get? I'm going to get that y is equal to 2x plus 3. Okay, that's my first bit. So now I'm going to substitute. We're going to substitute in the 2x plus 3 for y. So we've got 3x minus 2 times 2x plus 3 is equal to 0. Fix that 2 so it looks a little better. All right. So now we use distributive property. 3x minus 4x minus 6 is equal to 0. We add, sorry, not add, we're going to combine like terms first, and then we're going to add. 3x minus 4x is negative x minus 6 is equal to 0. And again, I can easily get my x variable to the other side. And so I'm going to do that. I'm going to add x to both sides. Since it's equal to 0 on the right, I get my variable positive. I save a step. And so I get that x is going to be negative 6. And so now I'm going to use that in my equation up above here. And we've got y is equal to 2 times negative 6 plus 3. Y is equal to negative 12 plus 3, which is y equals negative 9. So my ordered pair is negative 6, negative 9, and that's my answer. I would highly encourage you to check your work and use one of the original equations to double check that your solution works. All right, letter B. If I'm looking at this top one, I'm seeing that I can easily get that positive y by itself. All I have to do is add x to both sides. And I get that y is equal to x plus 4. And I'm going to substitute x plus 4 in for y in this bottom equation. Now, this is where it gets a little bit tricky, right? So we have negative 2x minus, we put parentheses down, okay, and we've got x plus 4 is equal to 2. So that negative sign needs to distribute to both terms on the inside there. So I'm going to get negative 2x minus x minus 4 is equal to 2. My next step is to combine like terms. Negative 2 minus 1 is negative 3x minus 4 equals 2. We're going to add 4 to both sides. Negative 3x equals 6. And our last step is to divide by negative 3. We get x is equal to negative 2, which we're going to substitute in up above. Y equals negative 2 plus 4. Y is equal to positive 2. So my ordered pair is negative 2, comma 2, And there we go. That's our answer. Go ahead and turn to the next page, and we have letters C and D at the top there, and those are going to be your you-try problems for this one. All right, letter C. If I'm looking at my bottom equation, I see that that is easily solvable for x. So I'm going to subtract 3y from both sides, and we're going to get that x is equal to negative 3y minus 7. And that is what I'm going to substitute in for x in my first equation. So we have 6y plus 5 times negative 3y minus 7 equals negative 8. And we start by distributing 6y plus negative 15y minus 35 equals negative 8. Okay, combine like terms. 6y and minus 15y is minus 9y. Minus 35 equals negative 8. We're going to add 35 to both sides. Negative 9y is equal to 27. And then we're going to divide by negative 9. And y is equal to negative 3, which we're going to substitute in. X is equal to negative 3 times negative 3 minus 7. Negative 3 times negative 3 is 9 minus 7. X will be 2. So my ordered pair is 2, negative 3. That's my answer. All right, now if we take a look at our next one, letter D, we have 7x minus 3y equals 2. We have negative 2y plus x equals negative 6. It's the bottom equation that I'm easily going to be able to manipulate. So 2y is going to be added to both sides. We've got x is equal to 2y minus 6. And I'm going to substitute in 2y minus 6 for x in my first equation. And so I get 7 times 2y minus 6 minus 3y equals 2. All right, we're going to distribute. We've got 14y minus 42 minus 3y is equal to 2. My next step, combine like terms. 14 minus 3 is 11y minus 42 equals 2. We're going to add 42 to both sides. 11y is equal to 44. And we divide by 11. We get y is equal to 4. And now we substitute that in for x. X equals 2 times 4 minus 6. X is going to be equal to 8 minus 6. X equals 2. So we have 2 and 4 as my two values. That's my x and y. All right. Now we're going to move on to example 3. We're going to use substitution when there's no solution or many solutions. So how are we going to do this? Well, we're going to follow the same process. Substitute in 5x minus 2 for y. So we have 3 times 5x minus 2 minus 15x equals negative 6. Distributive property, we get 15x minus 2 minus 15x equals negative 6. And you see where this is going already. 15x minus 15x is 0, so we have negative, and that's negative 6, not negative 2. And so we have negative 6 is equal to negative 6. So this is infinitely many solutions. Actually, this time I'll write the word out. Infinitely many solutions. All right, that means these are the exact same line. If we were to solve it for y, both of these would be the same slope, same y-intercepts. They are the same line. It is infinitely many solutions. It is IMS. It's an identity. All right. Letter B, what's this going to look like? Well, I have 4x minus 9 that I'm going to substitute in for y. So we get 4x minus 9 minus 4x equals 6. 4x minus 4x cancels out, and we got negative 9 is equal to 6. That is not true, so this is no solution. So you remember all the way back in the beginning of the year when we were solving and we got no solution and we got identities? You were solving systems of equations back then, and you did not know it. Pretty sure back then I told you that that's what you were doing. All right, you're going to try letters C and D on your own, and then check your work against mine. All right, letter C, y equals 2x plus 1. That's what we're going to substitute in for y. So we have 4x minus 2 times 2x plus 1 is equal to 70. You could probably see where this is going already. 4x minus 4x minus 2 is equal to 70. Combine your like terms, and you get negative 2 is equal to 70, which is not true, so this is no solution. And letter D, we're going to substitute in negative 3y plus 4 for x. So we have 6y plus 2 times negative 3y plus 4 equals 8. We start with distribution. 6y plus negative 6y plus 8 is equal to 8. And when those cancel out, we get 8 is equal to 8. So this is infinitely many solutions. Infinitely many solutions. All right, let's take a look at problem 3, our first word problem. Using systems of equations. You pay $22 to rent 6 video games. The store charges $4 for new video games and $2 for older games. How many new games did you rent? All right, so our first step here is we need to define our variables. So I'm going to say x is new and y is old. And now we've got to stitch together our pieces of information into two distinct equations. We are told we pay $22 to rent 6 video games. $4 for new and $2 for old. That's all of our information. How are we going to do two equations out of this? Well, let's look in at the 6 video games part. Our 6 video games are going to be our new games plus our old games, right? That's the combination between them. So we have x plus y is equal to 6. Our 2 video games, our new games plus our old games is going to be equal to 6. That's how we use the first piece of information. And then we're going to use the second piece of information, the fact that it's $22 total, and we had $2 for old games and $4 for new games. So we have $4 times new games plus $2 times old games is equal to the 22 that you spent. So now we need to figure this out. I'm going to, it says how many new games did you rent? So I want to be having new, the x value, as what I'm starting with. So I am going to solve for y, because if I solve for y, it's going to give me, we're going to take y out of the equation. We're going to take the old games out of the equation. So we have y equals negative 6x. That we are going to substitute in here, and then we'll be left with just x, which is our new games. So we have 4x plus 2 times 6 minus x is equal to 22. And we distribute. We have 4x plus 12 minus 2x equals 22. Combine like terms. 4x minus 2x is 2x plus 12 equals 22. Subtract 12 from both sides. 2x equals 10. And then if we divide both sides by 2, x equals 5 new games. So we're going to have 5 new games that we've rented. How many old games then did we rent? We can do that math really easily in our head. 6 minus 5 is 1. So we rented 5 new and 1 old. Although the question only asked us how many new games, and that's what we have. All right, let's take a look at letter B. A school bookstore sells t-shirts for $8 and sweatshirts for $12. Last month, the bookstore sold 37 t-shirts and sweatshirts for a total of $376. How many t-shirts were sold? So let's define our variables. That's always our first step. X is going to be t-shirts, and Y is going to be our sweatshirts. All right. And let's start to stitch together what are our pieces of information. Well, I know that t-shirts are $8, sweatshirts are $12, and they had a total of $376 in sales. So I can stitch that together. And so we have $8 times the number of t-shirts plus $12 times the number of sweatshirts. And that's going to be equal to the $376 that they earned total. Now, if I look at my equation, I'm also told they sold 37 t-shirts and sweatshirts. So my second equation is going to be x plus y is going to be equal to that 37. The number of t-shirts plus the number of sweatshirts equals the 37. All right, so now we need to figure out what we're going to solve for. What are we looking for? What do we want? We want how many t-shirts were sold. So that means I need to eliminate sweatshirts. So to eliminate sweatshirts, we're going to solve for y. So we're going to subtract x from both sides of our equation. Y equals 37 minus x. And that is what I'm going to substitute in for y right here. And that should have been a y, not an x. So we're going to substitute that in right here for y. And we'll have t-shirts instead of sweatshirts. So let's do that. We've got 8x plus 12 times 37 minus x is equal to 376. All right, so now we need to do our distribution. And when we do that, we're going to get 8x plus 12 times 37 is going to be 444 minus 12x is equal to 376. All right, so next one, combine like terms. 8x minus 12x is negative 4x plus 444 is equal to 376. And now we're going to subtract 444 from both sides. And when we do that, we get negative 4x equals negative 68. And we divide by negative 4. And we get that x is equal to 17 t-shirts. Okay, so we have 17 t-shirts. That is our answer. All right. Letter C, I want you guys to try on your own and then compare your work against mine. In a talent show of singers and comedy acts, singing acts are 5 minutes long and comedy acts are 3 minutes long. The show has 12 acts and lasts for 50 minutes. How many singing acts and how many comedy acts are in this show? So for this one, it really doesn't matter which one we solve first because we're going to solve for both of them anyways. So let's start with looking at the time. So singing acts are 5 minutes, comedy acts are 3 minutes, and it is 50 minutes long. Now let's define our variables. X is going to be singing. Y is comedy. All right. So when we stitch those two pieces together, we have 5x, 5 minutes times the singing acts, plus 3 minutes times the comedy acts is going to be equal to the 50 minutes total that we had. We also know that the show has 12 acts. So that is going to be our singing acts plus our comedy acts is going to equal 12. All right, so it doesn't really matter which one of these two that we solve for. I'm going to just solve for y. So we're going to subtract x from both sides, and y is equal to 12 minus x. And we're going to substitute that in to our equation right there. So 12 minus x goes in for y, and we're going to have 5x plus 3 times 12 minus x equals 50. Okay, so we start with our distributive property. 5x minus 36 plus 3x equals 50. So next step is to add 36 to both sides. Actually, no, we're going to combine like terms first. We're going to get 8x minus 36 equals 50. Add 36 to both sides. 8x is equal to 86. And when we divide 86 by 8, we get something that's not right. All right, let's look for our mistake here. We have 5x plus 3y equals 50. And we did... All right, so let's see. Negative 3 times 12x, that's negative 36. Negative 3 times negative x plus 3x. Okay. Because it's not minus 3. It's 5x plus 3y. So that should be a plus right there, which means that we should have plus 36, and we should have minus 3x there, which means that these signs are reversed. And this is why you should check your work as you go. So this would be plus 36, and then we're going to subtract 36 from both sides. And then 50 minus 36 is 14. But it was 5x minus 3x, so that's 2x. All right, let's just erase back to the place that I made my mistake. Okay, so my first mistake was right here. Okay, that I accidentally wrote as negative. So now that we've corrected it to be positive, we're going to redo this work and we're going to fix it. So we distributed. 3 times 12 was positive 36, and 3 times negative x was minus 3x, and that's equal to 50. Now we're going to combine our like terms. So 5x minus 3x is 2x, plus 36 is equal to 50. My next step is going to be to subtract 36 from both sides. And I get that 2x is equal to 14, which I will then divide both sides by 2, and my x is 7 singing acts. And if I'm going to take that, I'm going to substitute it into the other equation to get y. So we have 12 minus 7. 12 minus 7 is going to give me 5 comedy. All right, so working through example C there, that is a prime example of why having number sense is important. Because as soon as I started to get through my way through that answer, I realized that that wasn't right. Something was wrong there. And so I had to look back into my work and check and see where my mistake was and figure out what I needed to change. And we did that. And this is a prime example of why you want to try to think your way through the problem as you're doing it and have kind of an idea in your head of how these numbers are going to shake out. All right, that's the end of our notes for today, though. If you have any questions, please bring them to class tomorrow. Otherwise, have a great night.